Hello, everybody. Going through question number 4. I'm trying a new video method here today, so let's see if this works. Nice to see you all. Thanks for coming. This is question number 4 from the 2015 APCalculusBC exam. It's a very classic differential equation problem. This is where the 2015 exam takes a little bit of a hit, a little bit of a turn, and it starts to get a little bit more challenging, particularly on the last part. So the first couple parts are not so bad. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So these are the 6 points. Basically, to apply your rubric here, 1 point for all the slopes when x equals 0. So when x equals 0, that's this column. So this one needs to be just slightly less steep or closer to horizontal than this one. As long as that's the case and this one's slanted upward, you get that 1 point. And in this column, you have to have a horizontal line here at this point. This is going to come into play later in the problem, but this is 0.12, by the way. So at 1, 2, the slope of the tangent line is horizontal. We will come back to that in a moment. And then this one needs a slant upward, and this one steeper than that one. So here's your 2 points for the first part. As for the second part, find the second derivative in terms of x and y and determine concavity for all the solution curves on the differential equation. So the first part's not bad. The second derivative, this is implicit differentiation. So the first derivative is equal to this, and then when you derivative this, you take the derivative of 2x, which is 2, and then when you take the derivative of y, it's dy dx, or y prime. But it says in terms of x and y. So that's why you need to go back and substitute in what dy dx equals here, which in this case is this. Now you do have to be careful. You do have to have the parentheses around this, or you needed to have distributed the negative in. If you left these parentheses off or didn't distribute the negative in, like it is over here, then it's technically incorrect because that negative affects both of these parts. Now, for the second part here, determine concavity for all solution curves in the differential equation. So in quadrant 2, the x is negative and the y is positive. So when you do this, if the x is negative, a negative times a negative is going to be a positive, and y is going to be positive. So therefore, all the solution curves in quadrant 2 are going to be concave up because second derivative determines concavity. So there's no way in quadrant 2, if you think about it, that's over here, all the x's are negative and all the y's are positive. That will always yield a positive result. So 1 point for the actual second derivative, but it must be in terms of x and y, and 1 point for explaining that it's going to be concave up always in quadrant 2. Now for part C, it says let y equals f of x be a particular solution to the given differential equation with this initial condition. Does f have a relative minimum, maximum, and neither? Usually when you see particular solution, it means separate variables, but that's not the case here. It's asking you for a max or a min at a point. So the best way to do maxes and mins at a point is the second derivative test. So the first thing you're going to want to check is you're going to want to check to make sure the derivative at this point is going to be equal to 0. If it is, then you have a possible max, a possible min, or it could still be neither. You'd have to check the second derivative, which you already did in part B. However, it's kind of easy here because once you check the first derivative, you don't get 0. You get a positive 1. Therefore, the function is increasing at x equals 2. So it has neither a minimum nor maximum. And basically, it's just because that first derivative is not equal to 0. So if you consider the first derivative, it doesn't even have to be right if you got it wrong because it says the word considered. So if you somehow use the first derivative in your explanation, and then to get the second point, that's how you get the first point. To get the second point, you have to have the neither, and you have to explain why not. This part D is a doozy. I would say a huge chunk of my students do not understand this section or this question, and that's okay. It is worth 3 points, and to get the 7, 8, 9 here is going to be a challenge. Up until this point, it has been kind of easy. This is what the rubric gives me. Now there's multiple ways to do this problem, but the first thing I would look for is, do you have an answer as m equals 2 and b equals -2? I'm going to work backwards on this one. If you do, you get the answer point. Now, according to this rubric, somehow, somewhere, you had to have thought of that dy dx is basically m, or the slope of the tangent line. If you have that calculated anywhere, the derivative of mx plus b is going to be m. You're going to get this first point. And then if you also are able to associate the dy dx is also equal to m, you're going to get the second point, even if you don't get the right answer. Now, I have an alternate way to do this than going through all this, and I think I'm going to explain my alternate way first. But first of all, I just want to make sure you understand this part D in full. It says, find the values for m and b for which this is a solution. When something is a solution to a differential equation, it means it's the original problem. So to wrap my head around this, this is the way I went. So if your dy dx equals this, if a solution is a line, that means the original equation is a line. Therefore, y equals, this is an example, 2x plus 7 is an example of a line. Well, if this example is the original problem, what's the first derivative? The first derivative is going to be the number in front of the x, the slope of the tangent line, 2. What about the second derivative? Well, the second derivative of any line is always going to be 0. So if you took the first derivative, like you did in part B, and you take its derivative, you get this. Derivative of 2x is 2. The derivative of negative y is negative y prime, or dy dx. And if you know the second derivative has to be equal to 0, you can bring the y prime over to this side, and you can say, hey, y prime has to be 2 in this situation, because if you take the derivative of the first derivative, you're going to get the second derivative, and the second derivative will only equal 0 when this dy dx, or y prime, is also 2, because 2 minus 2 is 0. So right away, that gives you your m value. Now, the other thing I said is I was going to go back to that original slope field, and if I looked for where the slope is equal to 2 by calculating the slope field, there's one point that I had to graph, but there are others that are available, and that point is 1, 0. So the way I did this problem is I said, okay, if I know the slope has to be 2 by this calculation of the second derivative, and I know one point gives me a slope of 2, that's 1, 0 from the original slope field, I then substituted in 1 for x and 0 for y, and I solved for b, and that's how I got my b. This method would definitely give you those 3 points. Going back to here, this was very hard for a lot of students to understand, but just really quickly going through this, you can pause if you need more time to look at it. But if you took the derivative of y equals mx plus b, you get m. So that's kind of like how you get that first point. And then if you said m is equal to this dy dx, which I kind of showed you up here, you could then go back and take the 2x minus y, and set that equal to m. And then this is why this is confusing to understand. They put the x's together, and then they put the non-x's together by putting these together by bringing the m over the other side. So this is your slope in front of your x, and this is your constant b, and you know these have to be 0 when you bring this all over. So if you do that, you do know that 2 minus something has to be 0. That's the only way you can get an answer of 0. And then that'll give you 2. So if you get 2 here, you put that in. So then negative m plus b must also equal 0. And if you move the m over to the other side or the b over the other side, you're going to get negative 2. This rubric and the understanding of this is quite difficult. I wouldn't lose a lot of sleep over this. If you pretty much generally understand the idea and how to assign points, that's okay. If you got a 6 on this one, that's perfectly fine. This is a challenging problem, but I would like to say this. This happened in 2015, and it was back-to-back with nearly an identical problem in 2014. And I remember back to 2015 when I assigned the 2014 problem, a lot of students didn't understand it, but some of them really cranked it out and made sure they understood it so that when they came in at the 2015 testing situation, they actually had a pretty much of a leg up. But the average or below average students who struggle with some of this just kind of call it quits on that. Good job, everybody. Thanks for sharing. Good luck in your studies.